first paper, first unit is the inorganic chemistry. So in that inorganic chemistry, first topic is the chemical bond. What is chemical bond? Bond, it acts as a bridge in between the two atoms or elements. So that is known as a bond. So the bond present in that chemical molecules or atoms is known as a chemical bond. So in this chemical bond here, we discuss about the ionic solids. So what is ionic solid? Ionic solid means here the solid, it is with ionic bonds. It is known as a ionic solids. Ionic bond means here, what is ionic bond? Ionic bond means here the bond is present in between the two atoms. So here these two atoms, in between these two atoms, here it is the ionic bond. So how to explain it is the ionic bond? Means here these two atoms are with opposite characters. So one, it is ready to donate the electron and another one is ready to gain the electron. So these two are the opposite characters. So now we see the best example of the ionic compound, that is the sodium chloride. Sodium chloride is the best example of the ionic compound. So in this sodium chloride, one is the sodium and another one is the chlorine. So first we take the sodium, its atomic number is 11 and chlorine, its atomic number is 17. So here its electronic configuration is 1s2, 2s2, 2p6 and 3s1. It is the electronic configuration of the sodium. And next one is the chlorine. Chlorine, its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. So now we see the valence shell. What is valence shell? The last shells with same energy level is known as the valence shells. So the sodium 3s is the valence shell and chlorine 3s and 3p is the valence shell. So in this sodium here, in their outermost shell, it is with 1 electron. So here it is ready to donate the 1 electron. Means here sodium is ready to lose its electron. So after losing here, sodium, its electronic configuration is 1s2, 2s2, 2p6. So means here we see the completely filled electrons, means outermost shell it shows the octet rule. So here it lose 1 electron, means here sodium it is with the positive charge. And next chlorine. So here their outermost shell it is with 7 electrons. So removing of that 7 electrons is very difficult. So here the gaining of 1 electron is very easy. So here the chlorine is ready to gain that electron. So after gaining electron here, chlorine it get the outermost shell configuration is 3s2, 3p6, means after gaining of 1 electron, chlorine it is with octet rule. Okay, here it shows the octet rule. So here it gain 1 electron. So then here it get the negative charge. So here these two are the opposite characters na. So these two opposite characters combined and it forms a NaCl molecule. Okay, it is the example of the ionic bond. Sodium chloride is the best example of the ionic bond. So in this ionic solids, here we see the two types of energies. So in which one is the lattice energy, and next one is the solvation energy. So what is lattice energy and what is solvation energy? First we see the lattice energy. So lattice energy means here the minimum amount of energy is required. So here it separate means here that ionic solids are converted to gaseous ions. Okay, ionic solids are converted to gaseous ions, means here solid is converted to gas. That energy is known as the lattice energy. And next one is the solvation energy. So solvation energy means here the minimum amount of energy is released. So the minimum amount of energy is released when that ions are surrounded to that solvent molecule, that is known as a solvation energy. So here the balance between them means here this lattice energy and solvation energy, it is explains the solubility of the ionic solids. Okay, here the balance between the lattice energy and solvation energy, it explains the solubility of the ionic compounds. What is solubility? Solubility means dissolving capacity is known as a solubility. So here the ionic compound, it is the pure ionic compound, or otherwise here it is the ionic compound means here it is with more or equal lattice energy, means here this solvation energy is nearly more or equal. So then here it shows the ionic compound. Simply ionic compound means it is dissolved. So here it energy, that solvation energy is greater than or equal to the lattice energy, then here it is considered as a pure ionic compound. Okay, next we see the Faison rule. So chemical bond means here we see different bonds are there. Ionic bond, covalent bond, covalent bonds are there. So here this Faison rule is useful to explain the nature of the bond, means here whether it is ionic bond or covalent bond. So mainly here this Faison rule is predict to explain the nature of the pure covalent bond, means it is explains about the ionic bond based on the polarization. Okay, here according to Faison rule, it explains the ionic nature based on the polarization. So here we follow some conditions, then only here it explains it is the ionic compound or covalent compound. So here according to Faison rules, here it is the ionic compound means we follow some conditions. So what are that conditions? One is the that cation. Okay, here atom means here it is with the anions and cations. Anion and cation it combines, then only it gives the molecule. So here the cation, it is with more size, means it is with a large in size. And next one is the anion. Anion, it is with in size it is small. And next here this anion or cation, any one or both, it is with charge. That charge it is with low charge. And next one is the it is with inert gas configuration. Okay, it is with inert gas configuration means it is completely filled. That is the general electronic configuration is the Ns2 Np6 is the general electronic configuration of the inert gases. So here we observe these conditions. So then here it shows the ionic compound. So here we see the one example, alkali iodide. So what is alkali? Alkali means these are the first year group elements. Okay, in that first year group elements, here we take the potassium, rubidium and cesium. So it is the potassium iodide, rubidium iodide and cesium iodide. So we go down the group. So here it is potassium, rubidium and cesium. So we go down the group, here size of the cation is increases. So then here the covalent nature is also increases. It is about the Faison rule. Next we see the polarization and polarizability. It is very important topic. Polarization and polarizability. So what is polarization and what is polarizability? Polarization means here separation of the ions within a molecule is known as a polarization. So polarizability, it is the tendency of ions electron cloud to distort that electric field is known as a polarizability. Generally here, the difference between this polarization and polarizability. So polarization means a distortion of the cations and polarizability means here it is a distortion of the anions. So here this difference, it gives the degree of the covalent character. Okay, the difference between the polarization and polarizability, it gives the degree of the covalent characters. So there is no any universal single formula for that polarization. So here that polarization can be explained number of many bases. We see one simple formula, that is the polarization is proportional to charge of the cation to the radius of the cation. It is one of the formula. There is no single universal formula. Many formulas are there to explain the polarization. So here we see one example, that is we take Mg plus 2 and Na plus. So in these two examples, which one is more polarization? Simply here magnesium, it is with plus 2 charge and sodium, it is with only 1 plus charge. So here it is with more charge. So then automatically here this magnesium Mg plus 2, it is with more polarization compared to the sodium. And next we take the Cu plus and Cu plus 2. So here in which one is less stable? Generally here this Cu plus, it is the unstable. See here Cu plus, it is with 1 positive charge and here it is with the plus 2 charges. Means in these two examples here Cu plus 2, it is with more hydration energy. So due to that here more hydration energy, it is the stable and here it is the unstable. And next we see some examples of the polar and non-polar molecules. So how to explain the polar and non-polar? Generally polarity or polarization is increases to the volume of electrons occupied increases. So generally here we take the large size atom and small size atom. So for example here we take two atoms, one is the X and another one is the Y. So here in which its electronic configuration is 6 and here its electronic configuration is 10 or 11 or anything. So what happened here? It is the small in size. Okay, small in size means in that atom here that electrons here tightly bonded and here the large size means sizes increases automatically. Here we observe the loose bonding. So the distance is increases from central nucleus to outermost shell. It is the reason. So here we see the one example, that is the water molecule. So water, it is the polar or non-polar. Water, its formula is the H2O. Generally water, it is the polar molecule. So how to explain it is the polar means here the water in which unequal sharing of electrons are takes place. Due to that unequal sharing of electrons here, water it considered as a polar, means water it is with polar in nature. So the compound it is with polar means in which unequal sharing of electrons are takes place. And also here one is the unequal sharing of electrons, and next one is these are asymmetrical. And next the central atom, there is unpaired electrons, it is with unpaired electrons. So polar means here the molecule in which unequal sharing of electrons takes place, otherwise it is in asymmetrical in shape and also it is with unpaired electrons. Okay, all these characters it shows that molecule it is in polar in nature. So non-polar means, so in which equal sharing of electrons are involved and here it is symmetrical in shape. So, what is asymmetrical and symmetrical? Asymmetrical means it doesn't give any two equal parts, is known as asymmetrical. So, after cleavage it gives the two equal parts, is known as a symmetrical. So, non-polar in which it is with equal sharing of electrons, and also it is with symmetrical in shape, and also in on the central atom. So, there is no unpaired electrons. Okay, these are the properties of the non-polar molecules. So, and here we see the one more thing, that is the generally polar compounds are dissolved in polar solvents only. Non-polar compounds are dissolved in non-polar solvents. For example, here we take the water. Already we know the water, it is in the polar in nature. In this water here we add the oil, and in another hand here we add the sugar. Okay, here you observe in that water you dissolve the oil. So, these two are not ready to dissolve. But here in that sugar it easily dissolved in water. Why? Because here this water it is with the polar in nature and oil it is in the non-polar in nature. So, here sugar is also in polar nature. So, polar compounds are dissolved in polar solvents and non-polar compounds are dissolved in non-polar solvents. So, it is about the polarity and polarization.